Hi everyone, this is a video to help with explanations for the size of lattice enthalpy and then also hydration enthalpy when you start changing the ion. So it's all about a comparison. So I'll just lift this up a little bit and you can see that a bit better. So what we've got here is just a couple of tips that I always do when I do these questions to make it a little bit easier. So the question could be about lattice enthalpy, it could be about hydration enthalpy, so you can see the one at the bottom is hydration enthalpy. You have to change your answers ever so slightly for these, but there's not a huge amount of difference. So there's just a couple of keywords that you've got to get in your answers as well there. So always write down the ions so you know what you're comparing. Sodium chloride and magnesium chloride, so there they are. So what I've done is I've highlighted the anions in pink and the cations are highlighted in yellow. So I'm going to compare each of them separately. So you can see the negative ions, the chlorines, are the same in both compounds. So it's not about the comparison of those. It's all about the comparing your sodium and your magnesium. So what you need to do for these is, as I said, just have a look and compare. Work out what it is that you're going to compare. I'm just going to raise this up a bit so you can see. There we go. So we're comparing your sodium and your magnesium. So there's two things to compare. You've got your tables all filled in here that you've done from the PowerPoint. So we know it's all to do with the ionic radius and the ionic charge, and you have to talk about each of them separately. So in comparison between your sodium and your magnesium, in terms of the charge, you've got 1 plus and 2 plus there for your comparison. And then in terms of your size, your magnesium is slightly smaller. So there isn't enough room on here in order for me to be able to write it out big for your model answer. So I've got a little bit of sort of clues here, and then I've got a model answer in a second to show you. So sodium 1 plus. Magnesium 2 plus, so your magnesium's got the bigger charge, a bigger charge than the sodium. Make sure you get the comparison in there. And your magnesium is also slightly smaller because as you go across the periodic table from left to right, there are more protons which attract those electrons, so those shells of electrons get pulled in to that positive nucleus a little bit more. So bigger charge and smaller radius, both of those things result in a greater attraction. So here's the model answer that I have. Alright, so I'm going to have to move my prop. There we go. So you can see there, so your magnesium has a bigger charge, 2 plus compared to sodium's 1 plus. That means a greater attraction to your negative ions. So this one's all about the lattice enthalpy. So you must say what that attraction's to, and it's your attraction between your positive ions and your negative ions. Or you could just say greater attraction between oppositely charged ions. Your magnesium is also smaller, which means that you've got that greater attraction between your negative ions or between your positives and your negatives. So because both of these things, bigger charge, smaller size, both result in greater attraction, that means that your magnesium chloride is going to be a more negative lattice enthalpy or more exothermic, if you want to look at it that way. Whenever you're doing these arguments, you can always do reverse arguments. So if you wanted to say sodium has a smaller charge with weaker attraction, and then say that your sodium chloride has a less negative lattice enthalpy or less exothermic, that would be fine as well. When you are talking about your enthalpy change of hydration, it's the same argument, you just need to change the wording ever so slightly. So this one here, you can see I've circled hydration enthalpy so that we know what it is we're going to be talking about attraction between. This one's just asking between a bromide and a chloride. So they've both got the same charge, so we can forget about the charge. It's all to do with the size of this one. And if you look at the periodic table, bromine is bigger, chlorine is smaller, whichever one you want to go for. So the chloride has a greater attraction for the water because it is smaller. And it's the water molecules that attraction's between, and that's what you must be saying. You must be talking about what the attraction's between. So the attraction between the water molecules is greater in your chlorine or smaller in your bromine, which is going to make your delta H hydration of your chloride is going to be more exothermic or more negative. And again, you mustn't say bigger or smaller, they don't like it because it's all to do with the charge as well. So you either must say more negative or more exothermic in order to get the marks for these. And you have to say what that attraction's between. Attraction for water here, attraction for oppositely charged ions up in this one. Make sure you talk about the right thing. You don't need to talk about, so for this one up here, you don't need to talk about sodium chloride as one whole thing. It's specifically about the ion.